Now we are going to see the problem in block diagram. Okay. So using the block diagram reduction technique, find the closed loop transfer function of the system whose block diagram is shown in figure. So by using the block diagram reduction technique, we have to find the closed loop transfer function of the system whose block diagram is given. So this is nothing but the given block diagram. So this is a given block diagram. Okay. So in this block diagram, we are having 1, 2, 3, 4 summing points, and 1, 2, 3, 4, 5, 6 and 6 blocks. You are having 4 summing points and 6 blocks. Already we have studied some rules for block diagram reduction. So first we have to analyze this block diagram and we have to check whether if any rule is applicable for reduction. So while analyzing this figure, these two blocks G2 and G3 are nearer, but here you are having a branch point. So you can't apply the rule as such. Why? Because if there is no branch point at here, then you can combine these two blocks. Okay, but there is a branch point in between these two blocks G2 and G3. So if you want to apply that first rule, that is combining two blocks in cascade. So if you want to apply that rule, what we have to do is we want to move this branch point before this block G2. Okay. So if you are moving this branch point before this block G2, then we can combine these two blocks into one block. Okay. So this is the first step. What we are doing is we are moving this branch point before this block G2. Okay, what we are doing, we are moving this block, moving this branch point before this block G2. Okay, so the step what you are doing is moving the branch point before the block G2. So please listen, when you are taking the branch point at this point, so here what we will be getting is, at this point we will be getting G2. G2 will be coming here. That G2 will be multiplied by H1. But when you are moving this branch point before this block, the G2 will not be coming. So what we have to do means, you have to add one additional block G2 to this feedback loop. Then only the thing what you are getting before moving the point and the thing what you are getting after moving the branch point will be same. So what you are doing is, we are moving the branch point before this block G2. So here what you have done is, we have moved this branch point before this block and we have multiplied a G2 with this feedback loop. Okay, so we have moved this branch point before this block and we have multiplied this G2 to this feedback path. Why? Because while you are taking from this point, we are taking G2 and we are providing it to H1. But when you are moving this branch point before this G2, the G2 will not be coming here. So what you have to do, we have to add this G2 as a block and we have to provide it to this summing point. Okay. Then when you are analyzing, these two are in cascade. These two blocks are in cascade. Similarly, these two blocks are in cascade. So you can combine these two blocks into one block. If you are having two blocks in cascade and if it is having a gain of G2 and G3, the gain of this combined block is nothing but G2, G3. Similarly, if the gain is H1 and gain is H2, the gain of the combined block is nothing but H1, G2. Now, here you are having two blocks. That two blocks you are combined into one block, that is G2, G3. Now, next is, here you are having a parallel block. This block G2, G3 and this G4 plus this summing point. This constitutes a parallel block. What it is? The blocks G2, G3 and the block G4, they are in parallel. So we can combine these two into one block, and the gain of this block is nothing but G4 plus G2, G3 or G2, G3 plus G4. Okay, so we are eliminating this parallel blocks G4, G2, G3 plus the summing point. It constitutes a parallel block. So we are eliminating this parallel block and you are getting a equivalent one. So after eliminating this parallel block, you are getting it as, after eliminating the parallel block, you are getting it as G2, G3 plus G4. Okay. And already we have moved this branch point before that block G2. Okay. Now, these two blocks are in cascade. This also you can combine it into one. So you will be getting H1 into G2. Now, what you are doing is, so here you are having a branch point. So while analyzing this figure, here there is a possibility of feedback loop. Here you are having a possibility of feedback loop, but here is a branch point. If you are moving this branch point ahead of this block or after this block, then it will become a feedback loop, and this loop can be eliminated. Okay. So while analyzing this figure, we understand that here you are having a possibility of feedback loop, but here there is a branch point. So if you are moving this branch point after this block, you will be getting one feedback loop. That feedback loop that we can eliminate. So now we have moved this. Now we have moved this branch point here. Now, from initially the branch point is at this point, that we have moved to here. So we have moved the branch point after this block. So initially we have taken it from this point, but now what we have done, we have moved this branch point after this block. So what we have to do means, initially the branch point is here. So after that we have changed the branch point from this point to here. So when you are taking this branch point here, this G2, G3 plus G4 will not come as feedback. But after moving this branch point to this point, this G2, G3 plus G4 will be coming into the feedback path. So we have to eliminate this G2, G3 plus G4. So what we are doing is, we are multiplying the signal by 1 divided by G2, G3 plus G4. So this G2, G3 plus G4 term will be eliminated. Okay. Now these three are in cascade. So if you are having blocks in cascade, then you can combine these blocks into a one block whose gain is nothing but the product of individual blocks. Now, so we have combined, and now we are having three. First you are having one this is nothing but one feedback loop. This block plus this feedback path plus some point. This all constitute one feedback loop. Here the type of feedback is negative feedback. So the transfer function is nothing but G of S divided by 1 plus g of s h of s. G of s divided by 1 plus g of s h of s. So this is nothing but the g of s and this is nothing but the h of s. So what you will be getting? G2 g3 plus g4 divided by 1 plus g2 g3 plus g4 into h2. Okay, instead of h of s you have to substitute h2, and in the place of g of s you have to substitute g2 g3 plus g4. Okay, so we can eliminate this feedback loop. So after eliminating the feedback loop, we are getting these two blocks in cascade. So these two can be combined into one block. So after that, you are getting another feedback loop. This block and this feedback path and this summing point. All these three constitutes another feedback loop, and here the type of feedback is negative feedback. So our reduced transfer function is nothing but, or reduced gain is nothing but g of s divided by 1 plus g of s h of s. Okay, so instead of g of s we have to substitute this term, and instead of h of s we have to substitute this term. So you will be getting g of s divided by 1 plus g of s h of s. Okay, so we can eliminate this entire feedback path. So after eliminating, you will be getting another feedback path. You will be getting another feedback path with g of s. This is the g of s, and h of s is nothing but h of s is equal to 1. This is the g of s, and at this here the h of s is equal to 1, and the summing point plus this block, and this can be considered as a block having h of s value is equal to 1. So again we are going to, the type of feedback is negative feedback. Again we are going to eliminate this feedback loop. So we are getting this one. After simplification you will be getting the C is the output and R is the input. This is the reduced transfer function. Okay, after reducing the block we will be getting the transfer function as g1 g2 g3 plus g1 g4 divided by 1 plus g1 g2 h1 plus g2 g3 h2 plus g4 h2 plus g1 g2 g3 plus g4. Okay, this is the reduced transfer function.